This trig graphs question, I'm not going to draw the graphs for you, but to illustrate the beauty of the maths and the use of double angles to try and solve this trig graph question. We often use general solution to get our finer details of our answers. And so you've got two graphs and they say show that fx, which is this graph, equals gx, which is this graph, can be written as this. And so this is what buzzes through my mind. When I see cos 2x, I'm immediately thinking double angles, and there's three options. But because in the answer everything I see is sine, and because on the other side there's a sine, the best option is the option that is the expansion that only has a sine in it. And so I choose cleverly that cos double angle. I personally like to take the square to the side that makes it positive, and so I'm going to take it across to the left hand side. The ones will cancel each other out, and then I take out a sine, and I'm left with 2 sine x plus 1 equals 0. So there I've answered this question. In this question, what they could ask us is they could ask us to solve for x, and all we'd do is we'd begin by making sine x equals 0 and doing a general solution, which I'll explore in more detail in another video. And I would make sine x equal to negative a half, and again I would tick the quadrants where sine is negative. I would get a reference angle, and I would work out all my other x answers. That being done, to get us going in question B, where they've worked out those x answers, the specific solutions were 0, 180, 210, 330, and 360. Now the question comes to determine the values for x, where f of x plus 30 equals g of x plus 30 between 0 and 360. This in itself can scare you if you see this in the middle of exam, but actually all you want to do is realize it's still f equaling g, which is all the hard work you've done up here and all the hard work that's been done to get these exact answers. And so all you really need to say to yourself is what answer comes out of this type of a bracket, and it's minus 30. It's like when you began factorizing and you had brackets and you had to work out the answers. They were just the opposite sign. And so all I'm doing is I'm taking the answers that I already worked out and I'm just minusing 30. If I'm minus 30 from 0, I'm minus 30, but that's not in the domain they want. If I'm minus 30 from 180, I'm on 150. If I'm minus 30 from 210, that's 180. If I'm minus 30 from 330, I'm on 300. And lastly, if I'm minus 30 from 360, I end up at 330. And so those are my answers. All that's happened visually, if you had these two graphs, is it's almost like a copy paste. The whole graph, both the graphs have just been moved in the same way. They've both been moved 30 to the left. And so they'll still intersect where they did, except those numbers will be 30 to the left. And that's how you end up with the answers that you got. I hope you enjoyed this cool video and the use of double angles and the use of shifting. If you did, please like it, subscribe to our channel, and share this with your friends. Thanks a lot.